Okay, thank you for coming. My talk is called Traffic Analysis with Python and DPKT. And yeah, well, thanks for coming. As I said, I'm Kalisz. If you want to contact me, please do so at the email. I also have a website, adamkalisz.eu, and or feel free to talk to me after the talk, or if you have questions during the talk that are very immediate, then please do call on me and shout or whatever. And I understand English, German, and Czech, so I can translate if you need. So what will be the schedule for today? I plan on talking about 30 to 35 minutes and then having more time for Q&A, because sometimes the questions are more deep and I like to answer them thoroughly. I'll talk about what traffic analysis is. I will do some technical introduction very briefly. I actually think that most of you understand a bit of networking and maybe have a bit of programming experience, scripting experience. It won't be too bad. Brace yourself. And so nothing to worry about, but I will not talk about for loops or something. I'll present a survey of tools that are comparable with the purpose to Python and DPKT. I'll touch on ethics, because this is a very important topic in traffic analysis. I will show some examples. I'm sorry I don't have more examples, but I didn't have much time to prepare this presentation, and I also had some technical trouble with my laptop and static discharge. I'll talk about problems with DPKT, with the approach I have taken after some experience with it. I'll talk about future work, alternative approaches, so like very different approaches, but that solve the same problem that I have. Okay, so something that is very different to what I have taken, and then we will have plenty of time for questions and answers, hopefully. So what is traffic analysis? What is it good for? Why do we need it? We need to localize and correct communications related problems. Okay, so what is communications related problems? You set up a server and you cannot connect to anything. What do you do? How do you debug it? Yeah, you can have a look at your logs. Maybe the server isn't running. Maybe the packets arrive, but something is dropping them, for instance, the firewall or... Okay, so what can you do? You can dump the traffic and have a look if actually the packets arrive, if maybe they are malformed, and do something with it. Okay, so you can analyze them, analyze the traffic, and maybe it will help you solving some issues. You can also, traffic analysis can also help you understand systems. Okay, so you can verify that is basically, are we building the product that we need right? And validating is the other way around. Are we building the right product? Okay, so verifying is our approach correct, and validating is basically, do we do the right thing in general? You can scan for security anomalies. I'll show you an example that is just a few days old, actually, of ransomware hitting a network that I have seen, and some traffic dumps from this network. traffic analysis can help you reverse engineer some protocols, maybe, you know, for driver development. Actually, traffic analysis from in my talk will be related to Ethernet networks mostly, but nowadays you have packet-based networks pretty much everywhere, even in your CPUs. So I think in the next years, maybe you will do traffic dumps between cores or something as well, or maybe USB dumps. That is quite often the case if you need to develop some USB drivers, then you need to sniff the USB traffic, which is also packet-based. And yeah, well, you can also verify that you are using the resources right. For instance, if you have a small uplink and you really want to use it effectively for the business critical stuff and not for some YouTube videos that somebody is watching in their spare time at work, then yeah, you can find out about that, but be sure that you comply with the regulation in your company, because it might be illegal to do so. It can also help you with accounting. Again, the same applies. You need to make sure that you follow the regulation. And of course, you can be also malicious. I won't tell you that that's probably illegal, but that's what you need to do sometimes, or I don't know. I would advise you to not do it. So, a network traffic analysis is the examination of data flowing over a communications channel. It's this simple. So, in this diagram, we have two nodes, Alice and Bob, and a channel between them. It's some wire or some basic network, basically, like a single link. And what can we do? Where can we do traffic analysis? We can do it at Alice, between Alice and Bob, or at Bob, or at any of them together. Okay, this is just a very small example. You can imagine Alice being a network in itself. Okay, so this is just a very high level view, a theoretical entry. Okay, so can you read it actually, or is it okay? That's okay. I think it seems quite small on my screen. What are the components of traffic analysis? So now we are delving more into what we actually seek. So I'll start at the top. The traffic intercepting and recording. Okay, so I have talked about that. These are the traffic dumps that you need. It's the basic approach, because most of the time you cannot read the live traffic. It will not help you very much if you see hundreds of megabits of data flowing through. You will actually not see anything. Okay, and so it helps you if you can store the data to disk or somewhere and analyze it later and take your time. Then you can start analyzing the data and the metadata. So maybe the timestamps when packets arrived. Okay, so you can see, for instance, how long does it take to establish a TCP connection? How are the round trip times and stuff like that? It can really help you debug some problems. If you see that the establishment of TCP connections is very very different from the timing perspective, then maybe you have high utilization of your link, or there is some issue on a long haul network or something, or somebody misconfigured the system, like a quality of service policy somewhere maybe. You can find patterns. Okay, you can, as I said, for instance, timing patterns, or you can find that an IP address is trying to talk to the whole world on a single port or on something like that, which is an anomaly, something that usually doesn't happen. You can also look at the flags, for instance. In TCP, you have the reset flag and stuff, and when you see reset flags quite often, then maybe something's wrong. So maybe packets don't arrive, or yeah. That is, for instance, interesting if your database connections fail sometimes. Maybe you have too many database connections and the server is telling, okay, I can actually establish a TCP connection, but it's useless because I don't have any more capacity to service it. So there is a possibility to debug this. You can also find related metadata, such as from the data that you already have. You can extend these data by looking somewhere else and finding connections. Okay, so what you can find looking at an IP address, if it's a public IP address, you can find the AS number, for instance, the autonomous system number. So I don't know how many people know what an autonomous system number are, or is. Okay, so for those who don't know, that's okay. Internet is comprised of networks. So it's not one network, it's network of networks. And each network is an autonomous system. And has a number. So for instance, Telefonica would have one or more autonomous system numbers. And if they want to exchange data with somebody else, they will usually have an agreement with a different network, with a different AS number, how much data they are allowed to exchange. And this is regulated with the protocol BGP, Border Gateway Protocol usually. Okay, and this helps you maintain some policy for routing. So that actually, it's a technical solution to the contracts made between parties. Okay, so, and for instance, sometimes you see, okay, this from the AS number, you can see who is responsible for this IP address. So for instance, if I have, my logs are filled with IP addresses that seem not very common, then maybe I can look at the AS numbers, and if I see China Telecom or Alibaba or whatever, then I see, okay, it's probably some data center somewhere in central China. And I don't think we do business with these people, so something's probably wrong. Okay, so it helped me many times. Just a small aside, if you go to ripe.net, and I'll just, sorry. Do you see anything? Ripe NCC, and at the top right corner, you see a search bar right here. And if I say, okay, somebody has got to be responsible for this address, probably, I don't know, I just thought about some address, and now you can search, and it will tell you, okay, this is probably not in, okay, so this is the responsible organization. It's probably in Europe because it's managed by RIPE NCC. And you see some more information here when it registered, so it's an older network. Yes, and here is the AS number. Okay. So this, and it helps you, and this is like the whole network that they own. So it's quite a big network or medium network. You can read more about it there. That is a good starting point. current line. Perfect. Okay, you can also these metadata, these extra data that can help you with, for instance, geolocating these people, as I said, China Telecom, probably Central Asia, something like that. It can just get you started. You can also, if you have an IP address, you can look on blacklists, for instance, and stuff like that. DNS, who is DNS reverse record, something like this. You can then, when you realized what information you need and where to look, then you can automate this. You can write your tools that help you manage the copious volumes of data. This helps you keeping up with security, also the performance. Okay, so if you do the pointy-clicky things, then maybe you are not fast enough and you cannot keep up with the traffic that you have. You will not be able to see stuff all the time. It can also help you maintain some regulation compliance, because if you don't see as a guy the data, but you just process it automatically, then maybe it's a different area of law. Okay, and you have many other constraints that you need to keep up, and you don't have the time to do everything manually. Okay. One component of traffic analysis is thinking. You have to always think ahead. You have to always look at the data and try to connect the dots. Okay, so on the top you have some starting data, and then you go around the circle basically and collect more data, collect what you need, and then you have to look at it and try to answer the questions that you have. And if it doesn't work, then you have to start the circle again. Okay, you need to maybe dump the data at a different point in the network. Maybe it doesn't help you dumping the data at one client, but maybe you need to dump the data at the core router or something. Okay, and you have to iterate, and then it helps you with thinking. Maybe at a certain point in time you actually see the solution. And then if you have done all these things and you have clarity, then you can automate everything with the tools you have written. Sometimes it really helps if you deploy these tools to production and in an automatic fashion, then you should probably also do some sanity checks. Okay, maybe be sure that it also works when you do backups and the links are full. Okay, with data, maybe the performance wasn't good enough. Maybe it doesn't work in 2 years when you get a better link. Talking about performance, so network traffic analysis is difficult to do, because nowadays we have networks that are 1 gigabit, 10 gigabit, 100 gigabit even, or more, multiple of those. So what performance do we need? What is the time window that we have to process one packet? Okay, so I did my calculations, and the smallest packet that you can send is 64 byte with overhead Ethernet frame. Okay, and that is the smallest frame, but you have some overhead. So you use actually on the wire, you use at least 84 bytes of data per frame. And this can be a TCP ACK fits into this easily on IPv4. So how many such frames arrive on the typical ADSL line? Yeah, well, it's something like 190,000 per second. And so you have about 5 microseconds to process one packet. Easy. But look down the column, 1 gigabit, that is your typical home network. This is with the smallest packets, it's 12 millions of frames per second. And so you just have 84 nanoseconds of time to process one single frame. And to put that in perspective, that is about 200, maybe 300 clock cycles on your CPU. So it's not too much. It's actually, 84 seconds is about, nanoseconds is approximately the time that it takes to ask something, the processor takes to fetch something from the RAM, from the main memory. So you can fetch one thing and then you are done, you are too late. And then at 100 gigabits per second, this is insane. You just have 3 clock cycles to process one single frame. So you cannot do it in software, okay? Because you would be too slow. Or you need to use bigger packets, frames, whatever. And then you have more time. So what do we do at these speeds? You need to think about hardware acceleration or something, like special purpose hardware. And talking about special purpose hardware, there are some approaches to make the performance of network analysis better. You need to filter out what you need. So don't collect everything, just collect what you really need. And then maybe start small and then increase it, okay? If you find out I need more data, then okay. You can make your filters more or less fine-grained, actually. You can increase the amounts of data, but be careful because everything that you collect costs you performance dearly. So if you start your network traffic analysis and you want to solve some problem and you cause another problem by collecting data, then you have not helped anything. You can be smarter about capturing data. Maybe don't write to spinning Rust, maybe write to an SSD or write to RAM. You can make lossy captures in TCP/DAM. That is the snaplan option. You can basically cut the data from your packets that interests you. Okay, so just the first 100 bytes, and that's mostly enough for all you will need sometimes. You can do sampling. So for instance, if you have you just collect every 100th packet and do statistical analysis on it, and this helps you keeping up with very high-speed links, and it will get you the results that you need in most cases. And you can read about flows, what those are. It's basically that specialized hardware tells you, okay, somebody established a session here, and you just have the information. Okay, there is a session. It has this source port, this destination port, for instance, and when it was started, when it was closed, how much data was exchanged, stuff like that. So this also can help a lot, and it's just very little data, even though the link is very, very utilized heavily. If you do dumps in software, don't do too many context switches, do interrupt, stuff like that. Maybe put the threads that are collecting on a single CPU, or that the process is not scheduled to different cores every time. Use efficient data structures. That's pretty much the usual case in software engineering. Don't waste data. Use better interfaces if you have access to them. Use multiple cores. We now have 32 cores per system easily, so use them. It will help you. You maybe learn a bit of low-level programming and implement the inner loop of your analysis in C or something that is very fast. or use a library that is optimized. And if nothing of this helps, then maybe you have to think about something very different, but sometimes it also helps to try to offload stuff to specialized hardware. So usually you would use TCP dump or WinDump on Windows or Wireshark to do interactive traffic dumps. These tools are available pretty much everywhere. The Wireshark is a nice GUI for your traffic dumps. It makes the starting with traffic analysis easier, but it's really useful for the quick and dirty analysis, not something very methodical. And as I promised, this is the WannaCrypt dump from a network I have been watching 2 weeks ago. And you see, I hope is it readable up there? Kind of? Okay. You see these systems, like 2 or 3 IP addresses are so these are the source addresses, and the last number is the source port. And these are connecting IPs all over the world on a single port, 445. And that is the port, TCP port, that is used by Samba, by the file sharing, Windows file sharing. And you basically see that they don't receive any answers. Okay, so this is so they are just 2 or 3 systems are probing the whole world for Samba. Okay, so this is strange because they shouldn't be talking to the outside world at all. So we have to look at these systems, and this is very easy to do even with TCP dump. Yeah, it was an anomaly. It was something that was a good question. So the question was, how do I know it's WannaCrypt or something? Well, I don't know that. I know that afterwards when I look at the systems and find out there is some processes that shouldn't be there. And yeah, but it's an anomaly. It's something that shouldn't be happening, and I know who is causing it, so I can have a look. But if I didn't do the traffic analysis, then I wouldn't know where to look first. So I would need to look at every system and not just 3 systems in the campaign. So in this instance, to hinder it in the future, I would probably set up my firewall better or whatever, but I could also program it to look for this behavior and then tell me by email or something, hey, look, there are systems that are doing something nasty. Okay, so so a programming language and some library, this is the usual approach that you would take. It's a lot more flexible, but yeah, you need to program a bit. You can create your own tools with all the pros and cons. You can improve the performance because, for instance, TCP dump is single-threaded, and now you can do multi-threading if you know how to. Maybe you can even improve the tools and be more reliable. You can usually also generate packets to, for instance, prove that you are doing the right thing. Okay, so you can actually test stuff. And at the end, you can automate your analysis. So there are some example tools. A very popular option is Python and chatty, but I've used this, but it was too slow for me. So I would be able to, the analysis of 1 hour traffic dump would take 1 hour. So this is a bit too slow for me. So nowadays with DPKT, I do the same analysis in 3 minutes. So it's 20 times faster. The same thing. I have at the end I have the same data. You can probably look into the Go packet library. I haven't used that one, but it seems quite promising and seems to be supported well from the Go community. Google is involved in it, so it should be okay. I don't know much about Perl, but of course Perl can do everything, so maybe look there if that's your preferred option. If you like Wireshark from the GUI point of view and you want to automate just a little bit of it, then or do more with it, then Wireshark can be automated with Lua. So if you know some Lua, then that is also an approach. Or you can take the basis for TCP dump, which is libpcap, the library, and program something similar to TCP dump that suits you better in C or something Rust or whatever, C++. Or finally, you can take my way and use DPKT with Python. Before we delve into the examples, just a very quick note on ethics. Nowadays in Europe, IP addresses are considered personally identifiable information, PII. So be careful with what you do. If you are uncertain that you are allowed to do that in your company, wherever, ask and consult a lawyer. I'm sorry, but I don't want you to get into trouble because of me. And be considerate of people's privacy. Don't disturb. If you generate packets, don't disturb the normal traffic. Test it on some different network that you have under your control, and then maybe test again, and then yeah, make it into production. And of course, as always, don't be too confident about anybody's software. People make mistakes, so always check. Don't pipe some scripts to your shell and stuff without checking. So Python DPKT. It's a bit harder than Scapy. It's not that easy as Scapy, but it has a lot better performance. It also doesn't have such a great documentation like Scapy, but you will be all right, I think. Here is a very small example. So what you see here is we import DPKT and import socket, because DPKT is actually is trying to save cycles by not doing conversions all the time. So it doesn't convert IP addresses from hexadecimal automatically. So you need to do that. Okay, so this is the harder bit than Scapy, because Scapy will do that for you, but it will also be a lot slower. So I define a small function that can do this transformation, and then in basically the second half of the small script, I open a capture, a pcap file with some packets, and then do a small loop and read all the packets and write the source address of each of those packets. It's very easy. You should be able to extend it a lot more to make something suitable. So for instance, I have this, I've already taken the liberty and extended it a bit more. I'll just run the script, and you see that I have source addresses, source ports, destination addresses, and destination ports, and the script looks like this. Yes, whatever. I have probably opened it right here. So this is a bit extended. The structure is the same. You have some colors, and the printing is just a bit nicer. Okay, so I have nice columns and stuff. But yeah, that's it basically. I have it on the next slide, so you will be just without colors. Is it better? I'll post the slides online, so don't worry. This is the actual script. So this is just a very, very short start. I see I don't have much time, so I'll skip over one example and go to the problems. This is also just a bit too slow for, I mean, if I use DPKT with a fully utilized gigabit link, then that wouldn't be enough. That would be too slow. The problem also is with writing tools like this is you still need to write code with all the problems. If you don't do that, if you don't know how to program much, then you might be able to feel lost. And the DPKT community is of course quite small. As I said, the documentation is not very nice, so you should be able to read the source code and understand it easily, but it's still reading source code and it's not very friendly if you are not used to it. So what are the alternative approaches? Some people have written tools that may solve some problems. For instance, saving these reports of IP addresses and ports that have been talking to each other. And one such tool is PMACT. It's written by for some ISP people, so it should be performant enough. I think I know a network that is using it to do accounting on 10 gigabit links, so it should be okay. You can use the flow approach with NetFlow or SFlow. NetFlow is more Cisco and advanced switches and routers that are doing this. SFlow is pretty much on every managed switch that costs more than 100 euros. So you should be fine, but the tooling is very, you have to look out for the right tools, okay? Most of those tools will be paid, but there are some free tools for both NetFlow and SFlow. Here is a link to a book, not to some wiki page for NetFlow or SFlow, but to a book that explains both concepts in a nice, easy way and shows you how to use some free tools to use NetFlow and SFlow. And nowadays, you could also write a program that can be run directly inside Linux kernel. This is of course a lot harder than writing Python and DPKT, but it's also a lot more performant. It's something that Cloudflare would do when they want to sell you a new product. They usually use BPF extensively and with the associated performance. So this would be an approach that would enable you to scale beyond 10 gigabit per second traffic dumps, traffic analysis on live links probably. And well, thank you for your attention. I have taken a bit longer than I thought, but now I would like to answer your questions, maybe show another example, and yeah, whatever you like. So thanks. So the question is if I analyze just the metadata or also the contents of those packets, and the answer would be depends. It's quite hard to analyze the contents of the data if it's encrypted, for instance. So you have to rely on metadata most of the time. Sure. Yeah, you can absolutely do that. You can you could decrypt the traffic and then do the dump, but really depends on your jurisdiction at that point in time. I mean, you're not supposed to see the data probably. Yeah, of course, DNS traffic is usually not encrypted, and you can read a lot about, from out of it. So, for instance, if a client does DNS lookup and then immediately after establishes a TCP connection somewhere, then yeah, you can put 1 and 2 together. That is also what Paul Wixie told about 14 days ago at a different conference, that the DNS over HTTP isn't that useful at all for most of the dissidents and the people it's supposed to target, because, well, the DNS lookup is still out in the clear. So and you still need the IP addresses, the source IP address and the destination IP address anyway, with even when you got your information from DNS over a secure encrypted channel and nobody knew what the information is, they still see what you then follow with. So they will see, okay, the person is still, talking to this IP, and this IP is registered to New York Times, So, and if you are in Iran or North Korea, I don't know where, then it might still get you in trouble. So, yeah, it's mostly the metadata that really is the undisputable fact. Does it answer your question? So, yeah, and other questions, please. Yes. No, I haven't tried that, but that is what PMACT, for instance, would do. So you can connect PMACT to some to normal databases like Postgres or whatever, or to in-memory databases probably. I don't really know about that, but I guess they implemented it. But usually the file is just fine for short dumps, because you can save the file to temp, and then it's in your RAM and nothing's going to beat RAM. So, yeah. If there are no further questions, I might also show you a bigger script that is not fully done. It's still work in progress, but it might show you how you actually, from a small example, how you can extend it to make an actual tool that you can use on the command line, and that is more useful. Would it be okay, or do you have different questions that you would like to answer? Okay. Scappy, I might show that. And so it's similar from the structure. Yeah, you see it's more like here you see it's more like the dictionaries, and then you can put dictionaries in dictionaries, and this is basically how you take out your layers of the packet. So you start with an Ethernet and then go to the data portion of the data, and then you see, okay, this is the metadata of the inner IP packet, and then you go one step further and you see, okay, this is TCP or something. Okay, so you take the header and then you see, okay, this is what is inside, and then you go further and further. This is like an onion or something, and you peel off one header at a time, and then you read basically the inner information. And these headers are basically symbolized or abstracted using dictionaries mostly. So this is a very Pythonic approach to the problem, that you basically go dictionary in dictionary in dictionary, depending on if that's just Ethernet or also IP packet or TCP or maybe HTTP or something even. And you can go further. So this is the overall idea, and you will see the structure is pretty much the same because I had Scappy solution, and then I was not very comfortable with the performance, so I basically just translated it to DPKT. And you will see I have more helper functions. For instance, this inet to string, you have seen that already. Some documentation, and then I create basically an object that has a method of analyze capture, and then it goes through some steps and fills the right fields of the object basically, or the data in the object. And then for every packet I basically have an object, and then I can serialize it or write it to some file or something. And it enables me to work a lot easier with that. You see, it's more rudimentary in here. It's more, I need to be quite specific what I call, but it's still, I think it's still okay from the readability point of view. And I need to make it a lot more prettier, obviously, because I have lots of duplication and not fully done stuff. But what is the interesting part, what makes it a tool actually, is using the argparse library or module. And this enables me to make it a command line tool, basically. I can say, okay, here is a capture, and analyze it like this. Or so you see that I implemented how many packets it should take. So for testing purposes, I don't have to analyze 1 million of packets. I can just try first 1,000 packets and see if it works. I can also specify some time window, and this is basically the time slots in which I aggregate the data. So for instance, I could say, okay, I want to aggregate in 10-minute bins, okay, or 1-minute bins. And then I could say, okay, in the first 1 minute, 1 gigabyte of data was transferred. And in the second 1-minute bin in my dump, 10 gigabytes of data was transferred. And another set of IP addresses talk to each other and stuff like that. And or maybe at the 35th minute in the hour of the dump, there were 10 times more resets than usual. Something like this. And this would really help me find out where were the problems and where something started maybe. And so I could just use it probably. Yeah, and I have the test dump, that is the file that I used beforehand as well. And it's just a very small file. And bang, I can analyze it and write some data. So it's not really finished now, but it already works, produces some results, and I need to just make it more fine-grained and yeah, spit and polish. Okay, so are there any further questions? I think we have still got some 5 minutes. Or maybe inputs, critique. Okay, then thank you very much and enjoy the rest of Sunday.